Hello everyone, welcome to Thermo Green Innovation, a YouTube channel to share information on thermal system advancement with green energy integration. I am Dr. Devendra Raut, thermal system consultant. Welcome you to my YouTube channel on thermal system. Today's topic of discussion is in continuation with last video, and it is thermal energy storage. Before I move ahead with the detailed discussion, I would like to show you the content of this video. We will start the discussion with definition of thermal energy storage. We will discuss type of energy storage and component of energy storage. Thereafter, we will understand thermal energy storage with PCM, working of thermal energy storage, example of thermal energy storage with PCM. And after understanding this, we are expecting some outcomes, and the outcomes of this video will be understanding of the different thermal energy storage, components and construction, and working cycle of thermal energy storage. So basically, after getting insights on these points, you will come to know these points. What is thermal energy storage? Thermal energy storage. Have you any idea what is thermal energy storage? It is an energy storage device. It stores energy in the form of heat. Nothing, just it is a energy storage device and stores the energy in the form of heat. And that heat can be, if you are an engineering student, you definitely know that heat can be in a different form. Like heat can be sensible heat, the heat which can be sensed by the temperature, which can be measured by the temperature. Latent heat, the heat which cannot be sensed by the temperature and it is associated with phase change. Means that during the storage of this heat, there will be no change in the temperature. And one more, thermo-chemical, the heat released due to the chemical reactions. So based on the form of energy stored, thermal energy storage can be sensible, latent and chemical. So basically, this is the type of thermal energy storage. As we move ahead, we will see the working principle of thermal energy storage. The working principle of thermal energy storage is basically the transfer of the heat. So we will understand what is the working principle of thermal energy storage. The principle is like that: there is one device, it contains some medium, now it comes in contact with some heat source, like this wall is heating. So in the form of heat, flux coming, and the media may face temperature rise. Or it can go under phase change. Phase change phenomena can also take place. So in both the cases, the heat is transferred from one source and get stored here. When temperature changes, it is sensible heat storage, and when phase changes, it is latent heat storage. This is very basic principle of heat transfer which applies to the thermal energy storage. In most of the practical applications, the arrangement is like that. There is a passage of some heat source, or we can say hot fluid, or it can be cold fluid. In this case, we are considering hot fluid coming like this, and there is the storage media which is in direct contact with hot fluid passage via conducting wall. It could be metallic wall, SS, copper. So hot fluid goes, it transfers its heat to the surrounding media, and the media absorbs heat in the form of temperature or in the change of phase change. So in this way, the heat gets stored in thermal energy storage. Very simple principle. We will understand about the basic components of thermal energy storage. So question is, what are the components of thermal energy storage? There could be the components based on their function, like the components which brings heat to energy storage, and it could be a moving fluid, it could be a water, it could be a gas, it could be refrigerant. Another component is the component which can transfer heat to the energy medium. If the fluid is the medium, there should a component which transfers heat to the medium, and it could be a metallic structure like tube, plates, heating surface, anything, fins. Next component is the component which stores the heat in the energy storage. It could be a water, it could be a phase change material which actually does the job of energy storage. Another is media which removes the heat from the energy storage. The first and the second do the job of bringing the heat to the storage and extracting the heat from the storage. Both are important. When it brings heat to the energy storage, we can call it as a charging. When it removes the heat from the storage, we can call it as a discharging. So both are important. There is no use of storing the energy if we cannot make use of that stored energy. That's why discharging process is also very important. And the same, this media can be the heat transfer fluid, refrigerant also. Here also it will be the media. Another important is that outer shell for storage and protection purpose. Like we have to bound the material within a confined region. So outer shell is required, and it should be strong enough to protect it from the outside ambient or outdoor conditions, weather conditions. So it could be metallic, it could be plastic, non-metallic component, and it should be compatible with the phase change material or the medium which stores the heat. Now we have seen thermal energy storage. It can be sensible, it can be latent, and it can be thermochemical. So for our emphasis will be on mainly latent heat energy storage. I have done PhD in latent heat energy storage, and I found it is a very interesting and very promising technology to store the energy in future days. It has potential and it has its own advantage over sensible energy storage system. Now understand, latent heat we know there is no change in the temperature while the energy stores, your energy exchange take place. The component of latent heat energy storage will be the same as we discussed in generic, like there should be a media which brings heat to the energy storage. It could be a water, it could be a refrigerant. Another, the components which transfers heat to the energy storage. It could be a pipe, plate, heating surface, etc. The medium, the component which stores the heat in the form in the energy storage. It could be a phase change material, sand, and water can also be the phase change material when it stores the heat at after freezing. So it's a kind of cold thermal energy storage. Next is the media which removes the heat from energy storage. Again, it could be a fluid, air, and refrigerant. Now we understand the latent heat energy storage, and in the market the latent heat energy storage is known by various names like thermal battery, thermal energy storage, latent heat storage, latent heat energy storage, and latent heat thermal energy storage. So in our lecture, in our discussion, we will use the term thermal energy storage, or we can use the thermal energy storage with PCM. We can also use this term. So mostly I will be using this term, thermal energy storage. Both are all the names leads to the same meaning. Now we will understand thermal energy storage and its phases, like how the energy is being stored. Consider this is the arrangement, the helical coil heat exchanger. The tube represents the passage of heat. HTF means heat transfer fluid, and the surrounding volume, this volume is filled with PCM, and we can call this area as a PCM storage, and the coil is heat transfer fluid coil. The locations like that, the hot fluid will come from this side and it will come out from this side. So as the hot fluid comes in, if we plot the temperature with respect to time, as the hot fluid comes in, the temperature of here, temperature of PCM will rise. It will go like this, and once the melting point reaches, the nature of the graph will become horizontal, and once the complete melting of PCM takes place, it will again undergo sensible heating. So this is sensible heating, number one. Number two is latent phase change phenomena. So graph 1 represents sensible heating. Number 2 represents phase change. And when we are using solid PCM at ambient temperature, it would be melting. For hot storage, it is called step 1 is again sensible heating post melting. So this is the basic energy storage phases in thermal energy storage. So overall process goes like this. We are considering a PCM which is solid at ambient condition, and the temperature moves and its phase changes at melting point. This will be TM, melting point. So the entire process can be called as a charging of PCM, charging of thermal energy storage, and it goes like this: sensible, latent, and again sensible. I hope I make sense till here. So far we understood what is thermal energy storage and what are the types of the thermal energy storage like sensible, latent and thermochemical. We understood the components of energy storage. We understood how the thermal energy storage, we understood how the what is the thermal energy storage with phase change material. We understood the working cycle of thermal energy storage, and we understood example of thermal energy storage. So we understood one process, that is the charging of PCM, in which energy storage is taking place. In the next we will see the discharging. Once the PCM is stored, we have to remove the energy. So if this is a thermal energy storage, the Q amount of heat is stored, we have to extract the heat from some application. So it will be the discharging cycle, and the curve of discharging cycle will goes like this. It will start with the highest temperature in the system, T initial. First sensible cooling will take place, then phase change, then again sensible cooling with solid zone. So here it is sensible, phase change and again sensible. In this way discharging of thermal energy storage take place. Discharging, this is the zone of usable energy, or we can say the stored energy. I discussed this in my last video also. So combining of charging plus one discharging is equal to complete cycle of PCM and TS with PCM with PSCM. So we will understand why I said one charging plus one discharging is equal to one complete cycle, because in the specifications, or we can say characterization of thermal energy storage, the number of cycles, number of life cycles, or the number of cycles a thermal energy storage can undergoes is one of the important parameters. That's why it is very important to understand what is the complete cycle of thermal energy storage. So far we understood this point. So far now we covered the agenda of this video, that is the definition of thermal energy storage, type of energy storage, component of energy storage, thermal energy storage with PCM, working cycle of thermal energy storage, and thermal energy storage with PCM. Example of thermal energy storage with PCM. So we are able to answer that, yeah, understanding of thermal energy storage component and constructions and working cycle. Thank you.